Hey guys, it's Miss Applegarth, and this is Geometry, Module 7, Lesson 2. We're going to talk about parallelograms today. Our learning target is to use relationships among sides, angles, and diagonals of parallelograms. So I need you guys to grab your book, turn to page 413. If you were absent on Monday or Tuesday, and you don't have a book, you can just grab a blank one off the table. As long as nobody has their name on it already, then that can be your book. Okay, so go ahead and turn to page 413. Pause this video at any time if you need to take a moment to write things down. Otherwise, I'll be rolling through this. Okay, so we're going to learn about parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So, for example, here, BC is parallel to AD, and AB is parallel to DC. Other properties of parallelogram. So once you know something is a parallelogram, the next few items are automatically given to you. Opposite sides are congruent. So the top and the bottom are going to be congruent. The left side and the right side are automatically going to be congruent. Then if you have a parallelogram, then the opposite angles are automatically congruent. Opposite angles automatically congruent. So the angles that if you draw a line diagonally across your shape, the angles that it would touch are congruent. Fun part as well, our consecutive angles are going to be supplementary. So consecutive here means that you are right one after the other. Consecutive back-to-back victories, that means the one and then the next one are consecutive. So these two angles are supplementary, then these two angles are supplementary, these two angles are supplementary, and these two angles are supplementary. And supplementary means that they add up to equal 180. All right, last one. If a parallelogram has one right angle, then all four angles are right angles. So if just one of the angles in your parallelogram is a right angle, then because of this, consecutive angles are supplementary. All the rest of them have to be a right angle. All right, let's see how that goes into play when we're looking at parallelograms. So in example 1, so you guys, this is still on page 413. We're supposed to find CD. We want to find the length of CD. So we know that CD is congruent to AB. We know that the measure of AB is equal to the measure of CD. That's the definition of congruence. And then so we can say, what is AB? AB is 4 feet. So CD must also be 4 feet. All right, go ahead and turn that page to page 414. And I want you guys to pause this video, take a minute, and see if you can figure out what is the measure of angle D and what is the measure of angle FG. So the measure of angle D is, well, it is equal, it's congruent to its opposite angle. So D is opposite of angle F, which is 106 degrees. And FG is congruent to the side opposite ED, which is 8 inches. All right, moving along. We can use properties of parallelograms to write proofs. We are in example 2. We're going to write the correct statements and reasons. I just need a little arrow here so I can. We're going to write the correct statements and reasons to complete the two-column proof. We have parallelogram HJKP, and parallelogram PKLM. And we want to prove that HJ is congruent to ML. So you guys have to fill in the reasonings here. So parallelograms, HJKP and PKLM are parallelograms. That was given to us. And then we can say, because they're parallelograms, we can say that HJ is congruent to PK and PK is congruent to ML because opposite sides of parallelograms are congruent. That was one of the properties we looked at right here. Opposite sides are congruent. If you have a quadrilateral, that's a parallelogram, then its opposite sides are congruent. Okay. Then we have HJ congruent to ML when you have an item that is congruent to PK and then PK is congruent to ML. When you cut out this middleman and just say HJ congruent to ML, that's called the transitive property. Okay. You guys take a moment, pause this video, see if you can find the right reasonings and statements to complete this two-column proof. All right, so we have parallelogram JK, L, M, and we have KN, let's get a color we can see, congruent to KL. What's it called when we write down the things that we're given? Oh yeah, it's called given. If a quadrilateral is a parallelogram, its opposite angles are congruent. So we're looking at, we want to really focus in on J. So which angle is opposite J? Oh, that's right, L. So angle J is congruent to angle L. Isosceles triangle theorem says that angle L has to be congruent, so J is congruent to L, and then K and L has to also be congruent to L. So we can say, so if J is congruent to L and L is congruent to angle K and L, then we can cut out the middleman and say J is congruent to K and L. When we cut out that middleman, that is called the transitive property. All right, learn diagonals of a parallelogram have special properties. The diagonals have special properties. So if you draw a line from corner to corner, boop, boop, I know I'm so good at drawing lines. You guys are jealous. The diagonals bisect each other. So if you have a parallelogram like we do in example 3, and then just for fun, let's read this one. If a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. Oh, that's fun. So let's look at example 3 here and see how we can use this information to help us solve stuff. If A, D, C is 4x. So you guys, we just flipped the page, sorry. Sorry, you guys, we just turned the page. We are on 415. So if ADC is 4x and DAB is 2x minus 6. Then find the value of x. So we can say that when I add ADC and DAB, that's going to be equal to 180 because they're consecutive angles. Consecutive angles are supplementary. So ADC is 4x. DAB is 2x minus 6. So then I solve these by combining like terms. I'm going to bring it over here so we can solve it. So 180 equals 4x plus 2x is 6x minus 6. And then I add 6 to both sides. And then I get 186 equals 6x. And then I divide both sides by 6. And I get 31. So now you guys go ahead and pause this video for a minute. Find the value of C. Oh, I guess we're not pausing. Let's roll it. AE. So AE is congruent to CE. So we can say 3z minus 4 is equal to z plus 5. And then we're going to subtract z from both sides. We get 2z minus 4 equals 5. And then add 4 to both sides. And 2z equals 9. And divide by 2. Half of 9 is 4.5. So z is equal to 4.5. Okay, you guys, we are just about wrapped up here with our lesson. Thank you for hanging in. We're going to take a look at this example for our little scrapbooking. Tomas is making envelopes to sell with handmade cards. He uses a different style of paper. Get my little pointer guy. He uses a different style of paper to create the flap of the envelope, and he edges the envelopes with washi tape. The envelopes are parallelograms, and the edges of the flaps lie along the diagonals of the parallelograms. Find the area of the flap and the perimeter of the envelope. So here's this flap. And then we also want to find the perimeter of the envelope. So for part A, find the amount of paper you need to create the flap. We can approximate the area of the flap because it's the shape of a triangle. So the area is 1/2 base times height. We need to find this height. So to find the height, we want to know where the coordinates of intersection of the diagonals of the envelope, which has the vertices of -7, 7, and 7, -7. So we are going to go, and then CD is, C is -7, -3, and D is 7, -3. Because the diagonals of a parallelogram bisect each other, the intersection is the midpoint of AD and BC. Oh, right there. So let's find the midpoint of AD. So we're going to take the x's from A, so -7, and the x from D, positive 7. We're going to add them together and divide by 2 to get 0. Then we're going to take the y from A, which is 7, and the y from C, which is negative 3. Add them together, divide by 2. 7 plus negative 3 is 4, divided by 2 is 2. So we've got our point right here is at 0, 2. So now we have to find this height. I would just say count it. So you can go 1, 2, 3, 4, 5. You can just say it's 5. Or you can go, well, it's 7 tall and this is 2, so 7 minus 2 is 5. Either way works. All right, so now we need to find the base of this triangle. So we know that the height is 5. We need to find the base. Now, you can count it. And that's, so we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it is 14 centimeters as a base. Now we're going to plug that in. 1/2 base times height, so it's half of 14 times 5. 7 times 5 is 35. Okay, so that takes care of part A. Part B, find the length of the washi tape needed to create the border. That's all this guy right here. We just counted that this was 14. So the bottom part has to be 14 because it's a parallelogram. And then A to C, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 10. And this is also 10. So the length of the envelope is 14. The width of the envelope is 10. The little formula says 2 of the 14s plus 2 of the 10s is the perimeter. And that's 28 plus 20, which is 48. Okay, take a moment to do this check problem. Jimena is making a quilt. Each block is a parallelogram made of a single piece of pattern fabric and is trimmed with a gray border. Find the area of the fabric used to make the block. Find the length of the fabric used to make the border of the block. So we're finding area and perimeter of this little block. Take a moment, see if you guys can noodle that one through. Okay, so in order to find the area, we need to find its length times width. So to find the length, we can do distance formula. We need to do distance formula here. So length times width, we have, it's a square, so we're essentially going to find just one dimension and then square it. So I like to do like modified Pythagorean theorem. So to find this distance, we would go over 3, up 3, which turns into being 3 squared plus 3 squared is equal to our distance squared. So 3 squared is 9, so this would be 9 plus 9 equals d squared, which is 18 equals d squared, or d is equal to the square root of 18. So when we're trying to find the area, we're going to go square root 18 times the square root of 18. And if you can see it without using a calculator, good for you. If you need to put it in your calculator, no shame in that. This is going to be area of 18. Now, the perimeter is going to be 4, because there's 4 sides, 1, 2, 3, 4, times the square root of 18. You can put that in their calculator. There's no magical answer for that. It is just, we have to round it. It's going to be approximately 17.0. Okay, go ahead now and complete questions 1 through 4, 9 through 11, 13, 19 through 24, 28, and 29. It starts on page 417. Thank you guys for your time today.